Good morning all. Today we will discuss about the energy sources and power plants. Energy sources. There are two types of energy sources, renewable energy and non-renewable energy. Renewable energy, therefore here in renewable energy we will going to learn about the energy which is obtained by the windmill, solar energy, then geothermal and the hydro energy. Non-renewable energy. Non-renewable energy, the energy which is obtained by the coal, then thermal power plant, gasolines here, then difference between the renewable and the non-renewable energy sources. So renewable energy sources of energy will differentiate with the non-renewable sources of energy. In renewable sources of energy, it is also called as a non-conventional sources of energy, whereas non-renewable sources of energy, it is also called as a conventional sources of energy. In renewable sources of energy, they are available in abundant quantity and are freely. In non-renewable sources of energy, they are limited, hence account for the cost. Then next difference, the supply of these energies is inexhaustible and available continuously. The supply of these energies is exhaustible and will vanish in future. Next difference again, they do not create pollution and any hazards. Here in non-renewable sources of energy, for example, the coal, the energy which is obtained by the coal, they are creating pollution and the hazardous gases and which pollute the environment. And the last difference, the available potential of energy is diluted form, whereas in the non-renewable sources of energy, the available potential energy is high. Again, these are the few differences. For example, renewable sources of energy, the cost of extraction of energy to build power plant is very high. Here, the cost of extraction of energy to build power plant is very low. The energy is affected by different season in renewable sources of energy. The energy is not affected by a different season. The cost of extraction and storage is very high. The cost of extraction and storage is very less. The overall cost of the electricity produced per unit is high. The overall cost of electricity produced per unit is less in the non-renewable sources of energy. Example of the renewable sources of energy, as you know, it is a non-conventional. Uh, Solar energy, the energy which is obtained by the sun rays, then windmill, we have seen in the pictures, then hydro, then tidal, wave geothermal, ocean, and the biogas. So these all are the renewable sources of energy. Whereas the example of the non-renewable sources of energy and the conventional one, it is also called as the conventional, that is fossil fuels like coal, gas, oil, and nuclear energy. Then firstly, we'll discuss about the power plant engineering, that is the solar energy power plant. So it consists of the flat plate collector, that is solar collector, then the here the turbine. Turbine is coupled with the generator to generate the electricity, and the discharge is again supplied to the condenser, and then it is again fed to the solar flat plate collector. So the cycle is repeated for the solar. Okay, so here it consists of the solar flat plate collector which attract or which absorb the sun rays, and then it is converted, and the heat which is generated or absorbed by the solar energy, then it is uh, supplied to the turbine. So here the coolant, as it absorbs the solar energy, it get vaporized, and then that is a high temperature, high pressure coolant is supplied to the turbine. So after striking the turbine, it will get rotate. The fly, it will strike with high temperature and high pressure to the rotor, and it will get rotate. And by the phenomenon of electromagnetic induction, uh, here the electricity is generated. And then at the outlet, the low temperature, low pressure condenser, temperature coolant is supplied to the condenser again for the phase change. So in the condenser, we are supplying the cool water. After supplying the cool water, the condensation processes take place in the condenser, and here the hot water, the heat is absorbed by the water, and here the hot water is going out. Then that condensate, again it is fed to the solar collector by means of the feed pump. So these are all the basic construction and working details of the solar energy power plant. Then the hydroelectric power plant, as you know, the hydroelectric power plant is located where the main component of the hydroelectric power plant is dam. Then gate control, penstock is there, generators, and here the turbine is also there. Okay, the turbine structure here, the generator, turbine blades, and the impeller is mounted on the shaft of the turbine, and the shaft coupled with the generator, the stator rotor is there, and here you will get the electricity. So when we'll open this control valve, what will happen? The potential energy of the water is get converted into the kinetic energy, and here the huge concrete pipe is there. So that structure is called as a penstock. The anchors are provided here to support the penstock. The anchors are also there. Then high kinetic water jet is strike to the here the buckets of the turbine. It will get rotate, and as it will get rotate, you will get the electricity by means of this arrangement, generator and the stator and rotor. So this is how the hydroelectric power plant is work. There's schematic of the hydroelectric power plant. Here if you see, these are the anchors, penstock, reservoir is there, then inlet slice gate, dam is there. Dam is nothing but the wall, concrete wall which is built across the reservoir. So as we open the gate wall, what will happen? The initially the water is available in the form of potential energy, and after opening the wall, it will convert it into the kinetic, and then the high kinetic water particles with mv square, half mv square is striking to the turbine, and here we will get the electricity generation by using the hydroelectric power plant. Wind energy, next type of power plant, that is the wind energy. Here if you see the construction detail on the windmill, the wind turbine is also there. Electricity or electrical energy is converted here. The shaft, the wind rotor or the rotor is mounted on the horizontal shaft. Small electric generator is there, and here this is supported, this total structure is supported by means of the pole. So as airflow is there, naturally the wind energy or the kinetic energy which rotate this impeller, and as this impeller is connected or it is mounted on the shaft, by means of the electric generator we will get the electricity. Or here the kinetic energy of windmill is get transformed into the electric energy by means of the windmill. The device is called as a windmill. The turbine blades, it consists of the turbine blades, electric generator and the poles. Then steam power plant. Here, if you see in the steam power plant, it is again the structure is same as we have discussed earlier in the solar power plant. The boiler is there, then turbine is there, condenser is there, and the feed PEM is again the basic elements are the same. Only the flat plate, solar flat plate collector is replaced by using the boiler. The steam power plant, it is also called as the thermal power plant. So here generally the boiler shell, the abundance, the water is there in the boiler shell, in the boiler, it will get heated by means of the coal. So as the water is get heated, it will convert it into the high pressure and high temperature steam. So that high pressure steam is directed into the turbine. As it strike to the turbine, it will get rotated again. The impeller of the turbine is mounted on the shaft, and the shaft is coupled with the generator. You will get the electricity, and at the outlet of the turbine, you will get the low pressure steam. So to have the phase change again, to convert the steam into again the water, we are introducing here the condenser. So in the condenser, we are circulating the cold water. The when the low pressure steam comes in contact with the cold water, it will get condensate, and the condensation processes take place, and then condenses again feed or is circulated to the boiler by means of the feed pump. So this is how the thermal or the steam power plant is work for generating the electricity. Again, in the nuclear power plant, the basic element of the nuclear power plant, again, the boiler is replaced by using the nuclear reactor. The reflector nuclear reactor, it consists of the control rods, neutron deflector, reactor is there, then radiator, radiation shield is there. So here the nuclear elements are placed when the coolant after the nuclear reaction, the energy generated by after using after nuclear reaction, it is get absorbed by the coolant and it is circulated in the heat exchanger. So in the heat exchanger, the water is, when we are circulating the water, the heat exchanges take place between the hot coolant and the water. Here the water is get converted into the steam, and then the high pressure steam is directed into the turbine. Here you will get the electricity as it is coupled with the generator. Again that low pressure steam is directed into the condenser, and again by using this condenser, the condensation processes take place, and again it is refeeded to the heat exchanger. So this is how, by using the nuclear energy or the nuclear reactor, we are generating the electricity. So the plant in which we are using the nuclear element is called as a nuclear power plants. The other other process or the other mechanism is same, only we are replacing the boiler by using the nuclear reactor. Then the hydrogen energy. Hydrogen is nothing but an alternative to the conventional fuel. Hydrogen is an energy carrier, can be easily produced from S20 available in the nature. Hydrogen has highest energy content. The calorific value of the hydrogen is 150 kilojoule per gram. Non-polluting burning process. Again, this is one of the advantage of the hydrogen energy or hydrogen molecule. Difficulties in handling the hydrogen as production, that transportation, utilization, that is economy and safety and management. Reaction, if you take S2 plus O2, that is H2O plus energy. If we react the hydrogen with the oxygen, you will get the water S2 plus energy is liberated. It can be used as a direct or can be used as a raw material to produce the methanol, ammonia and SC. Hydrogen is chemically very reactive and hence it is not found in its free state. Heating value of S2 is nothing but 28,000 kilocalorie per kg. That is 3 times as that of hydrocarbons. Hydrogen is secondary fuel that can be produced by utilizing energy from primary energy sources. The application of the hydrogen energy, that is gas turbine, petrol engine, aircraft. A hydrogen oxygen fuel cell, this schematic diagram is representing an hydrogen oxygen fuel cell. If you see or if you compare this, if we hydrogen energy, these are the advantages. The renewable energy sources, in the advantages, if you see, clean energy source, it is non-toxical, so more efficient than other power space ship. Disadvantages, it is expensive due to low density of H2 storage, complication arises. Safest sources of energy, transportation of H2 is difficult. To separate H from oxygen, natural gas, coal, oil are required. Geothermal energy. Geo again, Greek word. That is, geo means earth and therm means heat. Again, this is again the natural kind of source which is available inside the earth. Energy that comes from the ground, power extracted from the heat stored in the earth. Volcanic action take place in many places on the earth's surface. Earth has a molten core. Then, for large scale, borehole are normally sunk with depth of up to 1000 meter, releasing steam and water at the temperature up to 200-300 degrees Celsius and pressure up to 3000 kilocalorie. So if you see, this is the production well. Again, this is the schematic diagram for the geothermal power plant. Production, here the steam is generated, and again that steam is strike to the turbine, it will get rotated, and by the phenomenon again, by means of the generator, the electricity is production. So there, as we know, near about, if we go deeper 1000 meter, the steam is available inside the earth, and the temperature of the steam is near about 200 to 300 degrees Celsius, and the pressure is 3000 kilocalorie. So that energy is utilized to produce the electricity. So that is how the geothermal power plant is work. Two methods of power generation. First method, the heat is transferred to the working fluid which operate on the power cycle. Generally occurs near volcanic action, 450 to 550 degrees Celsius. Second method, hot geothermal water or steam is directly used to operate the turbine. Generally, these sources are available in USA, Japan, New Zealand, Italy, Mexico, HP in India. The advantages does not produce, hence involve is greenhouse effect. Power stations are compact, low maintenance efficiency is good, no fuel is needed, plant are smaller in size. And the disadvantage of this plant, geothermal plant, sources is closely to volcanic region, energy difficult to transfer, high investment needed, loud noise, sources may trace amount of toxic chemical pollutant may contribute in the global warming. Then next type of plant, that is tidal energy. Tidals are the waves caused by the gravitational pull of moon and sun. Rise high tides and falls low tide. Tidal energy. So how will you define the tidal energy? Tidal energy is the utilization of variation in the sea level caused primarily by gravitational effect of moon combined with earth rotation. Water is present above sea level, that is flood tide. Water is present below sea level, that is ebb tide. Ebb tide. So if you see here, the high tide in here, there is a, in during the high tide, as the water is flowing from this side to this side, that is low, high to low, the rotor is mounted, and here as the rotor is rotated, the turbine is get rotated, our turbine blades are rotated, and you will get the electricity. And during again, that is from high to low, if you see, the reverse processes take place again. So this is how the energy obtained by the tidal or the tidal power plant is work. Application, Gulf of Kutch in Gujarat and the Sudarban in West Bengal. So these are where the generally the tidal energy is available. These are the places in where the tidal energy is generated and by which we can transform into the production of the electricity. Then biomass energy. Biomass is a renewable sources energy source that is derived from the living of recent living organism. Biomass include biological material, non-organic material like coal. Energy derived from biomass is mostly used to generate the electricity or to produce heat. Thermal energy is extracted by means of combustion, torrefaction, pyrolysis, and the gasification. Biomass can be chemically and biochemically treated to convert it to a energy-rich fuel. Differences: power producing and power absorbing devices. If you see, its performance is measured in terms of efficiency system. That is the power producing devices. Power absorbing device, its performance is measured in terms of coefficient of system. The maximum efficiency of the system may be 100% or always less than 100. The coefficient of performance may be 1 or more than. The flow of energy or heat is from source to sink. The flow of energy is from sink to source. Example, turbine IC engine, for example, heat pump and refrigerator. That is so heat pump and refrigerator are the power absorbing devices, whereas the turbines and IC engine are the power producing devices. Power producing devices, if you see the schematic diagram or the working principle of the power producing devices, just like the thermal power plant, as it is produced the power. The heat is transferred from source to sink, and the power absorbing devices, for example, the refrigerator is there. Again, it consists of basic element: compressor, evaporator, expansion valve, condenser. Compressor, condenser, expansion valve, and evaporator. The heat transfer, that is from the low body to the high body, that is again the some work is required to transfer it from the body at low temperature to the body at high temperature. So this is how the working principle or the device on which it work, that is Kelvin and Clausius statement, we are aware about it. The power producing devices work. Thank you all.